Have you ever wondered, if you traveled back in time and killed your own grandfather, would you still exist? This is the famous grandfather paradox in physics. On the surface, it seems like a simple logical paradox, but behind it lies deep questions about our understanding of causality, the nature of time, and even the very structure of the universe. Imagine you step into a time machine and travel back several decades, to a time before your parents were even born. If at that moment you accidentally killed your grandfather, then according to the logic of our world, your parents would never have been born, and therefore, you yourself could never exist. But here's the problem. If you don't exist, then who went back and killed your grandfather? This is the core of the paradox. Your change to the past breaks the causal chain that leads to your existence, throwing the causal order of space-time into chaos. But this is only the first layer of the paradox. The deeper question is time really something you can go back to? And if so, can the past actually be changed? In the world of Newtonian mechanics, time is absolute and one-directional. Past, present, and future are clearly separated, and no one can cross those boundaries. But Einstein's theory of relativity opened the door to new possibilities. In his general theory of relativity, time and space are unified into a single structure called space-time, which can be curved by mass and energy under certain extreme conditions, like near a rotating black hole or a wormhole. Closed time-like curves are theoretically possible. In other words, mathematically speaking, traveling back in time is not completely impossible. In 1988, physicist Kip Thorne proposed a theoretical model. If two wormhole mouths have a time difference between them, they could form a time loop. A traveler entering one mouth could emerge from the other before they even entered. Thus, time travel could become a concrete concept in theory. But precisely because of this, the grandfather paradox haunts the entire structure of the universe like a ghost. Would the universe allow such a logically contradictory event to happen? Some scientists believe it would not. The famous physicist Stephen Hawking proposed the chronology protection conjecture, suggesting there is some mechanism in the universe that prevents time travel from interfering with the past. He even joked, if time travel were possible, then why haven't we met any visitors from the future? To test this idea, Hawking once held a party for time travelers, but he only sent out the invitations after the party was over. And as expected, no one from the future showed up. However, other theories suggest the grandfather paradox simply reflects our limited understanding of the universe's multidimensional structure. This is where the many worlds interpretation makes a comeback. In quantum mechanics, there's a very influential interpretation called the many worlds interpretation, proposed by Hugh Everett in 1957. He suggested that every quantum event does not select a single outcome, but rather splits into all possible outcomes existing in parallel worlds. So when you flip a coin, both heads and tails occur simultaneously, but in different universes. So if you really went back and killed your grandfather, maybe you did not change your own past in your original world, but instead created a brand new branching universe. In that new universe, your grandfather is dead, so your parents were never born, and thus you do not exist there. But your original universe remains unaffected. In other words, in the new universe, you become a stranger who came from another universe, not someone naturally born on that timeline. Under this framework, the grandfather paradox is no longer a paradox, but a natural branching point in the evolution of the universe. Time is no longer a single line, but a tree that can split at any moment, with each branch representing a real possible world. But this raises another question. Who are you? Which version of you are you? If you go back and kill your grandfather, and thus create a world where you never exist, which world do you belong to? Does your consciousness continue along with the universe's branching? Or is each branching moment an invisible dividing line between your death and rebirth? This idea aligns with the logic of quantum immortality that we discussed in the previous video. If each split creates a new you, then is death merely the end of your consciousness on one branch, while it continues in another universe where you are still alive? The deeper fear is that we may never be able to verify which one is the real past. Because as soon as you try to change it, you cease to be on the original universe's trajectory. From this perspective, time travel is not merely a technical issue. It is a profound philosophical question about who am I? It challenges our intuition about causality, our understanding of free will, and forces us to rethink the definition of reality itself. Even more fascinating is the idea that the universe might not be a line running from past to future, but more like an immense, complex web of information. In some quantum gravity theories, time, space, and matter are just different expressions of information. The past is not a frozen video waiting for you to replay, but more like a set of data that can be rearranged. When you try to go back, it's like pulling a thread on this web of information. The originally fixed nodes shift and recombine, and the entire universe automatically adjusts other parts to maintain logical consistency and stability. So maybe time travel doesn't actually take you back to what was, but rewrites the past so that you appear there naturally. Even in the microscopic world, there are similar causal paradoxes to the grandfather paradox. For example, in quantum entanglement experiments, if you try to observe one particle first and then let the other particle decide its past state, you find that quantum systems don't allow you to form a closed paradox. They either reject your setup conditions or cleverly avoid contradictions, ultimately presenting a result that is consistent at the macroscopic level. It's as if the universe is saying, you can play at the edges of logic, but I will never let you flip the entire chessboard. Additionally, some scientists propose the self-consistency principle, which holds that the universe will self-correct any action that could cause a paradox. In other words, you might be able to travel back in time, but you will never succeed in killing your grandfather, because reality will fix the event in some way to preserve the causal chain. Maybe your gun jams, maybe you accidentally kill someone else, or maybe you simply can't get close enough to your grandfather. You'll find the past is as solid as a fortress. You're not a traveler who can change history, but a ghost carried along by history. Or you might actually kill him, but you will never be able to return the same way you came. That's like a quantum jump. From the observer's view, causality is unbroken, but you no longer exist in the original universe. In the end, we have to admit, the grandfather paradox is not just a physics problem, but a deep interrogation of freedom, existence, and destiny. It makes us realize that maybe time is not a river, but a vast, three-dimensional maze. We think we can flow backward through it, but every turn back might only lead us into another deep, shadowy passage. So, can you really change fate? Or is fate just a causal loop you can never escape? If your future self stood in front of a time machine, hesitating, what choice would you make?